Alright, so in this problem we are asked to determine the horizontal asymptote, if any, of each of the functions below. Let's just go ahead and do this first problem here. I have f of x equals x squared minus 4 over x squared minus 9. Now on Friday's lesson we were asked to find vertical asymptotes, and you would factor, but horizontal asymptotes you don't need to factor. All we have to do is make sure they're in descending order. Everyone say descending order. Descending order just says, x to the second. I don't have an x to the first, so that'll be 0x to the first, and then this would be x to the 0. The reason why you write descending order is just so that we can quickly see that this is the highest degree for both the numerator and denominator of this rational function. So I noticed that their powers, if you want to, you can just write it again, x squared over x squared. I noticed that the top degree and the bottom degree are what? They're equal. And if they're equal, then all it tells us to do is what? Reduce. What does it mean to reduce? Well, if I have a coefficient here of 1, and this is also a 1, I'm going to cancel my x squareds, and then I'm going to have a HA, horizontal asymptote, at y equals 1. Okay? Let's go ahead and take out your calculators and make a quick sketch of that. Go to y equals. Remember, when you have a rational function, basically a fraction there, you're going to start with parentheses. So parentheses x squared minus 4. And then I'm going to have x squared minus 9. I'm going to go ahead and do zoom 6. Okay. And you can see horizontally there's an asymptote right there, right? Now, if you look at the previous lessons, you'll see the other videos, you'll see that there's going to be a vertical at 3 and negative 3. So let's do a quick sketch. So there is a vertical asymptote at 3 and negative 3. Remember, use dotted lines. If you don't have different colors, even if you have different colors, use the dotted lines. And in today's lesson, we just found a horizontal asymptote at y equals 1. Now, if you had a table of values, I just want to reinforce the idea of horizontal. If you had a table of values here, and y is equal to 1, all of your y values are equal to 1. You can make up some x values, and you'll notice 0, 1, 1, 1, 2, 1. This is the horizontal line of y equals 1. There is my horizontal asymptote. And then I'm just going to go ahead and, based on what I saw on my calculator, and here now you're seeing that the graph is not touching that horizontal asymptote. That's the definition of an asymptote. It approaches but doesn't touch. So big idea, compare the highest powers. In this case, because they're equal, reduce it. When I reduce it, I get y equals 1, and that's my horizontal asymptote.